Today's lesson will be about plate boundaries and landforms. Here are our vocabulary words for today. Density of plates, crustal rock material, convergent boundaries, divergent boundaries, subduction, volcanic eruptions, earthquakes, spreading ridges, ocean basin, and transform boundaries. Our first word or words is density of plates. It's the amount of matter in a given space or volume. Oceanic crust is thinner and denser than continental crust. So remember last class we talked about how the entire Earth is covered in crust. The low spots is where the water settles, and the thicker spots is where we have dry land. So continental crust, where we have dry land, is thicker, and ocean crust, where we have the oceans, is thinner and more dense. Continental is less dense, ocean is more dense. So here's kind of a picture of this. We'll get into this bottom part here in a little bit. As you can see, this thicker continental crust is here, and the thinner, more dense oceanic crust is here. Our next words are crustal rock material, either oceanic, which is thin and dense, or continental, which is thick and less dense. So this just means the stuff that the crust is made up of. So even though the land and the ocean crust are made of similar elements, because they're all the same layer, they do have some different properties. The land is very rocky and loose. It has a lower density. The ocean crust is smoother for the most part and is a lot more dense. So again, we have another picture here. So we have our crust, continent here, oceanic crust here, which is part of the lithosphere, which includes part of the upper mantle. So this is all part of the crust. So you can see how it's a little bit thicker where the continents are and a little bit thinner where the oceans are. Our next word is convergent boundary. Convergent. It's when two plates move towards each other and collide. So this plate, the blue plate, is moving to the right, the purple plate is moving to the left, and so they're going to run into each other. And that is called a convergent boundary. They're moving towards each other. So here's a picture of a convergent boundary. This continental crust on the left is moving this way, and the continental crust on the right is moving this way. And so at this point right in here, they are meeting. And so that is called a convergent boundary. All right, so here we have divergent boundaries, and this is the exact opposite. It's when two plates move away from each other. So this plate here is moving to the left, and this plate here is moving to the right. And so they are spreading apart, they're moving away from each other. And what happens during that is that as they spread apart, magma from the mantle, which would be down here, is rising up to fill in that gap. And so this is where new land is made. So here we have another picture. Again, we have this piece of crust moving to the left. This part is moving to the right. And along this crack, they're kind of showing here, the magma flows up because it rises up to fill in the gap. And now we have new land along this space. So this is what's happening in the Atlantic Ocean. Every year, the Atlantic Ocean gets a little bit wider because the African and European plates are moving to the east, and the South American and North American plates are moving to the west. And so the Atlantic Ocean gets a little bit wider every year. This word is subduction. Subduction. When one plate is denser than another and is forced below as they converge at their boundary. Okay, so here we have two plates that are moving towards each other because this is a convergent boundary. This plate is more dense than this one, and so it's going to sink under the less dense plate. It's just like with density and floating. Whichever one has the higher density means it's going to sink, and whichever one has the lower density is going to float. And so we see that happening here. This plate here is moving to the right. This plate here is moving to the left. And so this plate is more dense than the one over here. So it is sinking down below. And what usually happens is that this plate eventually dips down so far that it gets into the mantle and it starts melting and becoming part of the magma that's under the surface of the earth. Volcanic eruptions is an event in which molten rock spews out from the mantle on the surface of the earth. Okay, so volcano is one of our best tool, I guess you could say, to study the different layers of the earth, because the magma that comes up out of volcanoes and becomes lava is coming directly from the mantle, which is kind of cool. So we have magma down here underground. When it comes up and erupts, then that becomes lava. And here's an awesome picture of that. All right, so our next word is earthquakes. It's the event in which plates shift and suddenly and release stored energy. So the plates build up potential energy as they sit, and then every once in a while they will move and release that potential energy and create an earthquake. So here we have one plate on the right, one plate on the left, and they have shifted. This plate on the right has moved upwards, and that has created an earthquake. And here's a real life example of that. All right, so here we have spreading ridges, or seafloor spreading is what it's called often. Spreading ridges. These are ridges formed from new crustal material at diverging oceanic plate boundaries. So when you have two plates under the ocean, which are spreading apart, this one's to the left, this one's to the right, again, that magma flows up and fills in the space. That is called a ridge. So if you look at it, in the middle of the Atlantic Ocean, there's this kind of scar-looking thing running down the middle of it, and that is where new material has been created and made the Atlantic Ocean wider. And here's how we see that again. This plate is moving to the left, this one's moving to the right. Magma rises up and fills in the gap, and it creates kind of a little bump, I guess you could say, along the line where it's doing that. Ocean basin is an area of oceanic crust covered by seawater and surrounded by areas of continental crust. So all of the oceans have this at the bottom. It's called an ocean basin. It basically just means like the low spot where the water is settling. And here we can see that we have our continental crust here on the left. Normally with the continental crust, it gradually starts lowering until it becomes the bottom of the ocean here. So this is like if you're ever walking on the beach and you go out to swim in the ocean and you're in the water but you can still touch the ground. This is where that's where you are here, because the crust is still high enough for you to be able to reach. And then as you go out further, the crust starts dropping down, and so now the water is much, much deeper. Here's a ridge like we were talking about before. When this magma rises up, it creates this kind of scar along the area where it's at. All right, and then our last word is transform boundaries. This occurs when two tectonic plates slide past each other. So we talked about convergent earlier, where the plates are sliding towards each other. We talked about divergent, where they're moving away from each other. And then transform, they're not really moving towards or away, but they're sliding past each other. They're like side by side, and they're just moving alongside each other. So this one is moving to the right, this one's moving to the left. But notice that they're not running into each other, and there's no gap created in between. So that's the difference with transform. They're just kind of sliding past each other. And you can kind of see that a little bit better with this picture. This plate is moving this way, this plate is moving this way, and they're just kind of moving along each other on this line. All right, so let's go ahead and do our guided notes. It's the movement of the tectonic plates. So the movement of the tectonic plates. This is a convergent boundary because they're moving towards each other. This one is sinking because it is more dense. And that again is called subduction. The theory of continental drift was discovered by a gentleman by the name of Alfred Wegener. There are three different types of plate boundaries. They are convergent, divergent, and transform. A transform boundary is when two tectonic plates slide past each other. So again, moving side by side, but not moving towards or away from each other. Divergent is when two tectonic plates move away from each other. So this one is moving to the left, this one's moving to the right, and then again that magma fills up the gap in between. A lot of people ask if this has anything to do with the Divergent movies and book series. It doesn't really, but the words do mean the same thing. So when we say divergent, we mean to move away from each other. And I haven't seen the movies, but I've heard that they are about a group of people moving away from their society or away from their government. And so it has kind of the same meaning. It means to move away from or to divide. So here we have convergent, when two tectonic plates move towards each other, and collide. Remember, collide means to run into each other. So this plate's moving to the right, this one's to the left, and they are running into each other in the middle. Here we have a picture of a divergent boundary, moves to the left, this one's moving to the right, magma fills up the gap. So this is when two plates move apart, new earth or magma comes up between. Here's a transform boundary, and this one is showing you what's happening in California, in the Los Angeles area, San Francisco area for the San Andreas Fault. So this is the Pacific Plate, which a little bit of California is on, and it is moving slowly to the northwest. So the Pacific Plate is moving this way. And the North American Plate, which most of California is moving slowly southeast. So it's moving in the opposite direction. So here, where those two plates meet along this area, is where we have a lot of earthquakes because the plates are sliding past each other. And this is an example of convergent. Convergent can have a couple of different things happen. So the more dense plate is forced underneath. We have ocean here, oceanic crust, and the lithosphere and asthenosphere that goes all with it. Ocean crust, remember, is more dense, so it's going to sink down below. And the continental crust is going to win because it is less dense, so it will float on top. When this happens, this is where we tend to have a lot of volcanoes, because as this dips down, this crust here starts melting, and then it starts flowing up into the volcanoes that tend to be at these boundaries. Okay, so the reason the plates move is because of these convection currents. And we talked about this in our energy unit. So as the material here, the magma in the mantle gets heated, it expands and becomes less dense, so it rises. And then as it gets further away from the outer core, which was its heat source, it cools off, contracts or becomes smaller, becomes more dense, and it sinks back down. So we have this cycle, just like in a pot of boiling rice, inside of the mantle, that creates these convection currents. So as these move around, the crust goes along with it. So if the convection current is moving to the right, then this crust is going to move this way. On this convection current, the crust above it is going to move this way. So at this spot, we would have a divergent boundary because these plates are moving away from each other. Okay, it's kind of a big shot of the entire page if you need that.